So this video is going to be on using Hess's law using formation data. So here's a real past paper question. So it says state Hess's law and use it together with the data given in the table below to calculate the enthalpy change for the following reaction. So pause the video and have a go at this yourself. So Hess's law states that the enthalpy change is independent of the route taken. So whatever this enthalpy change is when magnesium oxide reacts with hydrochloric acid, forming magnesium chloride and water, if we went a different route, so say we took the magnesium oxide and the hydrochloric acid and say broke them up into their individual atoms and then reformed them from the original, reformed these products from the individual atoms, that enthalpy change would be the same as going from here to here. Because the enthalpy change is the same, as long as you start off at the same point with the same number of atoms and you finish off with the same number of atoms, the enthalpy change will be the same. So this question is asking us to use, well, they've given us formation data. So the way you tackle a question is all to do with what data they've given you, because we could answer this question using bond enthalpy data, we could even do combustion data, but they've given us formation data, so that dictates how we attempt this question. So again, there are two methods to do this. There's the quick, easy way, and there's the longer way. You could be expected to do either. You are expected to be able to draw enthalpy cycles, that's the long way, or you could just do the shortcut, which is the quick equation. So we're going to start off with the long way first. So the first step would be to write the equation that you're asked to work out down like this. Sometimes they don't give you the equation, they expect you to be able to write the equation. If we draw two lines, and these are going to be arrows, these are going to be two separate equations, and they could be going down or up, down or up. We don't know yet. We've got to look at the data to figure that out. So we look at the data, we'll start off with this one here as its first. So this is the formation data for magnesium oxide. So what you need to do is you need to think back to a definition for formation. If you can't remember that, please look at one of the previous videos. So the definition for the enthalpy of formation is the enthalpy change when 1 mole of the substance is formed from its elements in their standard states. So what we need down here, the definition tells us we need the elements that form magnesium oxide in their standard states. So we have magnesium and oxygen. Magnesium's standard state is a solid, all metals except for mercury are solid, and oxygen is a gas, and it's diatomic, that's its standard state. It's never on its own in its standard state. Okay, we'll need to balance this. So you can see you've got one oxygen here, but two oxygens down here, so we'll balance that by putting a half here. Okay, if we look at the data, we can see that it's the formation of magnesium oxide. Because it's formation, whenever you see formation data, that always tells you the arrow is going towards it because you are forming it. So that means this arrow is going towards. We've also got the formation data of the HCl. So this is in the same arrow, the same step from here to here, we're also forming two HCl's. So we're going to need some hydrogen down here, again, in its standard state. So the standard state of hydrogen is also a gas and it's also diatomic. We need two hydrogens, so we don't need that's already balanced. We also need a chlorine. So I've put our chlorine over here, it doesn't matter where you put it. Okay, we can see we need two chlorines, we've got two chlorines. Chlorine standard state is also a gas and it's also diatomic. So that is that arrow. That arrow is forming the magnesium oxide and the HCl. What are the values? Well, it takes, to form one magnesium oxide, it gives out even minus 602 kilojoules. So we can write that on. For the magnesium oxide, it's minus 602. And then we've also got two HCl's. That's the energy given out when one HCl is formed. So we need 2 times that because we have 2 HCl's formed. So minus 92 times 2. So that we add those two together and we get the enthalpy change for this arrow. So this whole arrow is minus 786 kilojoules per mole, because the units are all kilojoules per mole. Okay, now we've got to work out this arrow. So we've got to work out two things about it. We've got to work out, is it going up or down, and what value is it, what's its total enthalpy change. So again, we look at our data we've been given, and you can see we've got the data for magnesium chloride and for water. They're both formation data, so that tells us that the arrow is going towards them. We are forming these, so let's put the arrowhead on. We need to check that everything balances. So have we got two chlorines? Yep. Have we got one magnesium? Yep. Have we got two hydrogens? Yes. Have we got one oxygen? Yes. So everything's balanced. If it wasn't, we need to add stuff here. This equation must balance with this equation. This equation must balance with this equation, and this equation must balance with this equation. Because you remember, Hess's law states that the enthalpy change is independent of the route taken, but that's only if you have the same number of atoms in each equation. So we can see we've got forming one magnesium chloride, so that's that value there, minus 642. We're forming one water, minus 286. So that comes out as minus 928. We're trying to work out the enthalpy change for this reaction, so we call it delta HR. So now all we need to do is the clockwise, anti-clockwise rule. So clockwise arrows equal the anti-clockwise arrows. So you can see which arrows are going clockwise. If you move your pen around, you can see that this one's going clockwise. So is this one, and this one's going anti-clockwise. It's going anti-clockwise, just this one. So that's our equation. We've got the clockwise, two clockwise ones equal the anti-clockwise ones. So let's just rearrange that and work out delta HR. So HR comes to minus 142 kilojoules per mole. So that was the long way. What's the quick way? So the quick way is, if you're ever given just one type of data, just formation data, just bond enthalpy data, or just combustion data, there's a few little equations you can use which can save you a lot of time. So this is formation data. If you see formation data, what you should think is you should think for par. So formation is products minus reactants. Don't ask me what the A is there for, so for par. As opposed to combustion data, which is crap, which is reactants minus products, and bond enthalpy data, which is BRAP, which is reactants minus products. You won't get the mark if you just write formation equals products minus reactants. You have to write for all of these three, you have to write it in a special way, which is like this. So delta HR equals the sum of delta HF products minus the sum of delta HF reactants. Now just writing that down whenever you see formation data is actually worth 1 mark. As long as you write down it as exactly as it is shown here. You may not write just products minus reactants, that's not worth a mark. Combustion would be almost the same, except you replace the little F with a C, and it's obviously the other way around, it's reactants minus products. Bond enthalpy is a little bit different. If you want to watch the video I'm going to make on bond enthalpy, I'll show you how to do the equation for that. Okay, then we just take the data. So we look at the products. We've got magnesium chloride and water. We see we've got one of that, one of that. So we put these values in, one of that value and one of that value for the products. So you can see we've got magnesium chloride minus 642 plus water, which is minus 286. Obviously we don't need to include the plus there because it just becomes minus 286. And then minus the reactants. So for the reactants, I'll put some brackets in. We've got, if we look at the reactants, there's our reactants. We've got one magnesium oxide, so one magnesium oxide is minus 602, plus we've got some HCl. We've got 2 HCl's, so plus 2 times minus 92. So let's do this one in brackets. So plus 2 times, whoops, 2 times minus 92. Close brackets, and we'll close the whole thing. So if you just throw all that into your calculator, being really careful to use brackets correctly, or even better, doing it separately, writing down the values for the products and then writing down the values for the reactants, and then you should get a value for your delta HR of minus, delta HI equals minus 142 kilojoules per mole.